So today we're going to be having a look at solving some practical problems using some of this trig solving we've been doing. So deliveries can only be made to Mathtopia via the bay when the depth of the water, y, is greater than 2 meters. The water levels in the Bay of Mathtopia can be modelled by this equation here, where t is between 0 and 24, where t is the time in hours after midnight, given suitable intervals for deliveries to be made. So we're really interested about when y equals 2 meets y equals 20 minus 24 cos of pi t on 6. Alrighty. And so we could solve this in a number of ways. We could try it algebraically, but if you try that, you'll find out that it's an exact value that you don't know. And in cases where you don't know the exact value, you actually can't solve it without a calculator. You might be able to estimate it at best, but you are going to really struggle to find solutions. So instead, let's use technology. I'm going to be using Desmos for today, but obviously you could use an alternative program. And you can see this is what the picture looks like. You've got this black function here, which is modeling the function, and we've got this line here, this red line here, which is modeling the tide at 2. Alrighty. So you can see in here all of these intersecting points, and there's multiple intersecting points. But remember, we're only interested between when x is equal to 0 up to x is equal to 24. This is the region that we're actually interested in. If it's outside of this region, we're not actually interested. I might even show that by putting a domain on my function, but I'm not too stressed about it for today. So now all I need to do is figure out what these intersecting points are. And it's quite easy on Desmos to just click on them. Obviously, if you're using gsolve, it's the intersect tool. And once you're typing in your two functions, you should be able to find these 4 intersecting points. So you can see that the tide is higher in between these first 2 points. So my first solution is going to be 1.38 is less than or equal to, oh sorry, it's got to be greater, so less than t, less than 10.62. And then for the next range, we can see that then it goes a little bit underneath the line. And then the next range is going to be these 2 points. So 13.38 less than t less than 22.62. Reminder, we're using t and x interchangeably. Desmos uses x as its explanatory variable, its independent variable, whereas in the question, t was given as our independent variable, but they're meaning the same thing. So let's just convert these numbers over to the page. So I've copied down all of my t solutions that I found for the range between 0 and 24. You can see I didn't get any that were larger than that. And now I'm just going to change them into intervals. And it's just really important that it's strictly greater than 2 meters. So it means that I don't want when it's exactly 2 meters, I want it when it's greater. So 1.38 less than t less than 10.62, or 13.38 less than t less than 22.62. But you may look at that and go, well, that's oddly specific. So there's a few ways you could deal with this. Option number 1 is that you convert these into hours and minutes. You can give it more like times. Or the alternative is that you round. So say, for example, on this one, I could round up to, if I wanted to do it to the nearest hour, I could round up to 2. I wouldn't round down to 1 because then it would be wrong. And I could round up here, round down here to 10. Alternatively, you could just round to the nearest half hour. So I could go 1:30 a.m. to, what would this be? 10. Oh, it would have to, yeah, round down to 10:30 a.m. That's another way we could write it. If I wanted to do it exactly, well, I'd need to just do the conversions. So 0.38 hours times by 60 equals 22.8. So I'm going to round that to 23, and so I get 1:23 less than t less than, same thing for the 10.62. 0.62 times 60, 37.2, so I'm going to round that down to 37, so we get 10:37 a.m. And I probably won't use the T notation anymore, I'd rather just give it as a time interval. And then we'll do the same, repeat the same process for these ones. Now this is going to be 1 p.m. to 10 p.m. and we'll just work out the minutes in between. But you can see that the decimal place is the same as the previous ones, so it's going to be exactly the same. So we're going to get 1:23 a.m. to 10:37 a.m. and then 1:23 p.m. to 10:37 p.m. And those would be suitable times to leave. Could definitely write a sentence or something, but that'd be about it. Alrighty, so that's just using some graphical solving. I'll see you in the next one. Bye.